Hello Science 10s! In this video we are learning about acceleration today, which is the measurement of motion. Acceleration can be an increase or decrease in velocity. So that sounds strange because usually we say acceleration is speeding up and deceleration is slowing down, but in physics we use acceleration for both positive and negative acceleration. So we can see the rate at which velocity changes can be an increase, a decrease, or even just a change in direction. Remember, velocity is a vector quantity, so it has a direction associated with it. Some examples: if you have a car speeding up at a green light, which is illegal, there's green light cameras, you shouldn't do that, but if the car speeds up at a green light, this is positive acceleration. We could also have a car slowing down at a stoplight or stop sign, which is good, and that is decreasing speed is also acceleration, negative acceleration. We could also have a car turning, so it could just be turning at a constant speed, going in a different direction. This is also acceleration. Now, were you just listening? Because you should be able to answer this question if you were. How can a car be accelerating if its speed is a constant 65 kilometers per hour? Well, this means that it must be changing direction. There, you can be a race car driver and accelerate all day. Now we're going to have to learn how to calculate acceleration, of course. So if the object is moving in a straight line, the units of acceleration are meters per second squared. We will also sometimes see kilometers per hour squared. There's Mario. To find acceleration, we take the final velocity minus the initial velocity, and we divide it by the time. Now the velocities are both measured in meters per second with the direction, and time is in seconds. So if they give you time in minutes or time in hours, you're going to have to convert it to seconds. We have positive acceleration. In this case, we may see that both the magnitude, the number of the velocity, and the direction are positive. This means positive acceleration. Or when the change in both the magnitude and the direction are negative. We also have negative acceleration. This happens when the change in the magnitude of the velocity is negative, while the direction is positive, or when the change in the magnitude of the velocity is positive and the direction is negative. To calculate acceleration, so we have a diagram at the bottom. We see a car that is starting at 0 meters per second velocity and ending at 16 meters per second. We'll say it's going eastward because that's the way it's flying across my screen. And this is from 0 to 4 seconds. So already we have a lot of information. Here's my equation. I know that the final velocity is 16 meters per second. I also know that the initial velocity is 0 meters per second. And because it's eastward, we're saying positive. The time is 4 seconds. Now I can put all that information into my equation. 16 minus 0 divided by 4 is going to give me 4 meters per second squared. I forgot the squared up here. Should be a 2 right there in the positive direction. So please put that in your notes. We have another question. We have a skydiver. He is accelerating from 20 meters per second to 40 meters per second in 2 seconds. What is the skydiver's average acceleration? So what do I know? I know that the initial velocity is 20 meters per second and the final velocity is 40 meters per second, but I don't know the acceleration. I also know the time, but apparently I forgot to write it down. So that's 2 seconds. I find my equation and put my numbers in. So 40 minus 20 divided by 2, calculate it, and find 10 meters per second. We can't forget about significant digits, so we look back over at the velocities. This gives me 2 significant digits. My time is in 1 significant digit. So actually, I should have this as 1.0 times 10 meters a second. I've made a lot of mistakes in this PowerPoint. I'm sorry. Okay, now we had to switch over because I'm going to show you how to rearrange the equation. So our equation for acceleration looks like this. Final velocity minus initial velocity divided by time. But sometimes they want me to find a different variable rather than acceleration. So I may have to find time instead. If I need to find time, then I'm going to have to do some algebra. To get rid of the t on this side, because it's being divided, I multiply. If I do it on this side, I have to do it on this side. Then I can cancel out the t. So my intermediate equation looks like this. Now to get rid of the acceleration, because it's being multiplied, I'm going to divide, and I'm going to divide. So my final equation looks like this. If I need to find time, I use that one. Now what if they want me to find, say, final velocity? So let's start with our equation again. And in this case, we're going to find final velocity instead. So I'm going to get rid of the time again. I got to move that over. And now I have the VF minus VI. To get rid of the VI, because it's being subtracted on this side, I'm going to add it. Which means I'm going to add it on this side. Those cancel out, and I end up with VF. So I can write it this way, VF equals T times A plus VI, because I like to write it with my variable on the left side. Okay, that's my second one. Now I may also need to find VI. So if I use this last one, VF equals T A plus VI, I can easily just subtract this part from both sides. And then, easy peasy, I have VI, which I forgot to write in green. Sorry, what am I doing here? VF minus AT. That's a little bit messy, but I think you can figure it out. So that's how we rearrange the equation. We put the square around it for our different variables. Now we're going to try some questions. Not that question, this question. Okay, so we have an object that starts at rest and accelerates at 1.30 meters per second squared north for 6 seconds. What is the final velocity of the object? So let's write down what we know. I know the acceleration and I know the time. Let's start. A is equal to 1.3 meters per second squared north. I know the time is 6 seconds. Oh, 0 there. And I need the final velocity. I don't know that. But initial velocity, even though it doesn't tell me, it does tell me it starts from rest. So that tells me that it's 0 meters per second. All right, so now I'm looking for final velocity. My final velocity equation that I got from my last page looks like this. VF equals T times A plus VI. Now I can just put in my numbers. 6 seconds plus 0 because it started at rest. What did I forget? I'm going to multiply those together and I get 7.8 meters per second north. I need a direction because it's velocity. I should put arrows. Do better than me, children. Okay, so there's my final answer. Now, how many significant digits do I need? I see I have 3 significant digits, so I should have 3 significant digits in my answer, which it was 7.80. Okay, next one. We have an object again dropped off a building. So imagining we have a building, probably it's some kind of squirrel that's dropped off the building, so I'll draw that for you so you can see my artistic skills, which have become very good. Perhaps it's like a flying squirrel. It looks more like a gargoyle, but actually looks awesome. So he's going to fall down. And what do I know? I know acceleration, and I know velocity, and I know he's initially at rest, so that tells me VI. So let me write that stuff down. Okay, so acceleration is equal to negative 0.981 meters per second squared. This is the acceleration due to gravity, so you can remember that. We're going to look at that later. VI, oh look, I'm remembering, is 0 meters per second, and VF is negative 49.1 meters per second. Yes, downward. Okay, and this is also downward. And what am I looking for? Time. I'm looking for time. What is the time? How long does this take? So let's find the equation for time, which looks like this from my last page. T equals Vf minus Vi over acceleration. Which means I'm going to put in my final velocity minus my initial and divided by the acceleration due to gravity, or the acceleration. When I divide this, I find that it is 5.005 seconds. Looking back up here, I see that I have 3 significant digits, so my answer has to be in 3 significant digits, which would make it 5.01 seconds. So the squirrel took 5 seconds to hit the ground. Please go back and make any notes and write down the worked examples so that you can do the work in class tomorrow.